Hello guys, this get lecture of engineering mathematics on topic higher order linear differential equation is brought to you by lecturesforfree.com. Hey guys, this is the 8th part of differential equation. If you haven't seen the earlier part, then I will recommend you to watch that also. Okay, so let's start and see the topics that we will cover in this lecture. In this lecture, uh, we will see basically about the particular integral. As we know, complete solution of any higher order linear differential equation is complementary function and particular integral. How to calculate complementary function that we have already seen in my previous lecture. Okay, in this lecture we will basically concentrate on particular integral calculation. So there may be different cases for particular integral. We categorize it as a case 1, 2, 3, 4, 5. Okay, so in this lecture we will see only about case 1 and case 2 in this lecture. Rest all the cases we will see in my next lecture. After that we will solve some sample question related to gate, and after that at last I will give you the solution of my challenge question that I have given in my previous lecture. So guys, let's start. As we know, complete solution of higher order differential equation is basically the complementary function and plus in particular integral. So as we can represent any higher order differential equation like this, function of d into y is equal to x, capital X. Here y represents the dependent variable. Okay, dependent variable. Capital X represents the independent variable, or you can say function of independent variable. Function of independent variable means in this case you can say it is a function of x. Okay, so in any equation like this complementary function depends on the auxiliary equation, and auxiliary equation is what? Auxiliary equation is fd equal to 0. For this in this we will get the roots of this equation, means the value of d which satisfies this equation, and from here we will get complementary function. Okay, and particular integral we will get it from this capital X. Okay, so for different value of capital X there are different method of calculating particular integral. Okay, so for different cases we will see in this lecture, but if you haven't remember my earlier lecture about complementary function, then let's revise it and let's see this slide here. If you haven't remember, you can pause my video and remember this. Okay, what are the complementary function when our roots are real, when our roots are equal and real, complex. Okay, so let's move forward and let's see the particular integral case first. Let's suppose you have a given equation like this, fd y is equal to capital X. In this equation, let's suppose your capital X is equal to, in first case, let's suppose your capital X is the exponential function of X. Means let's suppose your capital X is equal to e to the power ax. Okay, exponential function of X. Okay, so for this case, like this, if you know, as we know solution means basically solution of this function means we have to find the value of y. Okay, so from this equation you can write like y is equal to 1 upon fd into x, capital X. So this represents the particular integral. So you can write like particular integral is equal to 1 upon fd into capital X. Okay, so for this case means when your capital X is exponential function of x, means capital X is equal to e to the power ax. Okay, so our solution will be like this. you can write it like 1 upon fd e to the power ax. So solution of this will be particular integral equal to, here we will replace d with this variable x, means we will replace uh, wherever d in that equation we will replace it by a. So we will get solution like this, 1 upon fa into e to the power ax. So here you will get the particular integral of that equation. Okay, so here also under the condition your f of a, it should not be equal to 0, because if your f of a will be 0, then 1 upon 0 means it will, particular integral will be infinite, means it is not the right case. So our f of a should not be 0. But what sorry, but what if our f of a will be 0? If our f of a will be 0, then our particular integral will be, we will differentiate it, we will write like f dash a, means we will differentiate this d1 string and here multiply with x, okay, and e to the power x, means we will differentiate our this f of d one time, and after that we will put the value of a in place of d, and here we will multiply with x. Here also under the condition f dash a, it should not be equal to 0. Okay, but what if it is again 0? Then we will find particular integral like, again multiply with x, means here you will get x square and you will get 1 upon f double dash a, means again differentiate this, okay, again differentiate this, and then put the value of a in place of d. So you will get like f double dash a, and here you will again multiply with x, so you will get like this. Okay, here also under the condition f double dash a, it should not be equal to 0. Okay, if it will be 0, then I don't think I need to tell you what will be our particular integral. If it will be 0, then again we will differentiate it and here again multiply with x. Okay, so I think you get the idea. If you haven't get it, then if you will solve question, then you will get more idea. Okay, so let's solve one sample question. Now let's see this. Here equation is given, we have to solve this. Okay, so to solve this, here in left hand side differential equation is given, and right hand side your thing is not 0, means it is like this, f d y is equal to capital X. Here capital X is not 0. Okay, if it will be 0, then our don't need to find particular integral, but here our capital X is not 0, means here we will get complete solution, means y is equal to complementary function plus particular integral. So let's first of all find the complementary function of this equation. To get the complementary function of this equation, let's write this our equation in form of function of d, y is equal to x. Let's write it like this. Okay, so for writing like this, I am putting dy dx is, I am writing it as d, and d square y upon dx square, I am writing it as a d square. So our this equation will be like this, d square y minus 6 dy plus 9y is equal to 6 e to the power 3x, or you can write it like d square minus 6d plus 9 into y is equal to 6 into the power 3x. So here it represents your function of d, means it is like a function of d into y is equal to capital X. Okay, where capital X is your this exponential function. Okay, so to get the complementary function, we get it by auxiliary equation. Okay, what is auxiliary equation? Or auxiliary equation will be function of d should be 0. This is your auxiliary equation. We have to find the root of this auxiliary equation. Okay, we have to find the root of this auxiliary equation. So let's this is the function of d. d square minus 6d plus 9. This is the function of d. So let's equate it to 0. So you can write like this, d square minus 6d plus 9 is equal to 0. So you can write it like d minus 3 whole square equal to 0. D square minus 6d plus 9. Okay, d minus 3 whole square. So here you will get roots of this equation, means d is equal to minus 3, and since it is square term, so you will get minus 3 and minus 3. You will get two roots, and those two roots are equal, and that is equal to minus 3. Okay, so what will be our complementary function when we will get two real and same root? Let's see this slide. When we get two real and equal roots, okay, like here we are getting m1 and m1. So if we are getting two real and equal roots, then our complementary function will be like this: c1 plus c2x e to the power m1x. Okay, so in this case our m1 is like minus 3. So you will get complementary function is equal to c1 plus c2x e to the power m1x. So here m1 is our minus 3x. Okay, so this will be your complementary function. Okay, now let's find out the particular integral, because here capital X is not 0. So let's find out the particular integral. Our particular integral will be our like this: 1 upon fd into capital X. So our function of d is like d square minus 6d plus 9, and our capital X is like 6 e to the power 3x. Okay, so sorry, 6 e to the power 3x. Okay, so this 6 is constant, so don't need to worry about this 6. Here you are getting exponential function. Here this is a function of d. So what you have to do, you have to put 3 in place of d here. So here if you will see, like this is a function of d. Okay, so if you will put 3 here, means f of a means f of 3. So what you will get it 0, like here 3 3 are 9 minus 6 into 3 means 18 plus 9. So you will get 0, means you are getting f of a is equal to 0. So you directly cannot put 3 in here. First of all, you have to differentiate it. You have to differentiate it and multiply x. Like here as we have seen, f of a should not be 0. Okay, if our f of a is 0, then we have to differentiate our function of d one time. Okay, and multiply x here. So our solution here will be like this: particular integral will be multiply with x here and differentiate it. So d square, differentiation of this is 2d, minus 6d, differentiation of this is minus 6, and the plus 9 is a constant, so differentiation of this will be 0. 9 is constant, so differentiation of this will be 0. Now write here 6 into e to the power 3x. Now if you will put 3 in place of d here, now here this is represented the f dash d. Okay, now if you will put f dash a means f dash 3. So what you will get, f dash 3 means 2 3 are 6 minus 6 means again 0, 6 minus 6 again you are getting it 0. So you don't need to put here, you have to differentiate it again. Okay, you have to differentiate this again and you have to multiply here x once again. So let's do that. So you will get particular integral equal to, you will get like particular integral is equal to, here you will get x square, and if you will again differentiate that, then you will get a different 2d. Differentiation of 2d will be 2, and the minus 6 differentiation will be 0 because minus 6 is constant, and here you will get 6 into e to the power 3x. Okay, so here now we have no d here. Okay, now we have no d term here, so don't need to put 3 in place of d because now we have now we don't have any d here. So this will be your particular integral 2 3 the. So you will get like this 3x square e to the power 3x. This will be your particular integral. Okay, so now you have both complementary function and a particular integral. So your final solution means complete solution means y, this represents complete solution, is equal to complementary function plus particular integral. So your complete solution means y is equal to complementary function means this is your complementary function c1 plus c2x e to the power minus 3x. So write it c1 plus c2x into e to the power minus 3x plus particular integral. Particular integral is this 3x square e to the power 3x. Okay, so this is finally your complete solution. This is your solution of this equation. Okay, so this is your answer. Now let's see the second case of particular. Let's see the second case. So in second case, let our capital X these cases are nothing but the different types of value of X. Our X will be different, then there are different method of finding the solution. So let's suppose now our capital X is some sinusoidal or cosinusoidal signal. Let's suppose our capital X is like this, sin ax plus b or cos ax plus b. Let's suppose our capital X is like this, okay, sinusoidal or cosinusoidal. Then our particular integral will be like this. Particular integral, we can write it like a 1 upon fd, and here capital X means sin ax plus b or cos ax plus b. So in this case, let's suppose it is a function of d. So let's consider it's the function of d. It is some other function of d square. We have to mainly see the d square term. So let I am writing it like a psi of d. Phi of, you can let's say phi of d square means let's suppose this is a function of d square, means we have to write like a phi of d square. We have to consider only the d square terms. Okay, ax plus b or cos ax plus b, and wherever d square term is coming, put the d square is equal to minus a square. Okay, wherever d square is coming, put the d square equal to minus a square. So your this equation will be like this, phi minus a square, or here sin ax plus b or cos ax plus b. Okay, so here also we have same condition. Psi of minus a square, it should not be equal to 0. It should not be equal to 0. Okay, if it will be 0, then what we have to do? We have to do as we have done in earlier. We have to differentiate that term. So you will get particular integral like this. Particular integral will be first multiply x here, then differentiate this 5 days. You will like 5 days here, d square, here d square will come. So e to the power, sorry, no, not e, sin ax plus b or cos ax plus b. So now you are getting d square here. So now put in d square is equal to minus a square. Okay, so you will get x into 5 days minus a square. Okay, and here you will get like sin ax plus b or cos ax plus b. Okay, here also same thing. We have to condition like our 5 days a, it should not be equal to 0. If it will be 0, then we have to again differentiate this and we will get again multiply with x, so you will get x square like 1 upon 5 double days minus a square, and here like sine ax plus b or cos ax plus b. Similarly, this should not be 0. Okay, so this is like this same, but here we have to see the only d square terms. Okay, and we have to put d square is equal to minus a square. Okay, so now let's see the sample question related to this case. Now here question is as we can see, left hand side is some differential equation, and the right hand side is the some function that is cosinusoidal function. Okay, so this is a question like this type, because here capital X is your cos 2x, cosinusoidal signal. So you can write it like a function of dy is equal to x. Okay, how you can write? Put d by dx equal to d square by dx square equal to capital D square. Okay, so you can write it like a d square plus d plus 1 into y is equal to cos 2x. Okay, so solution of this, or I can say complete solution of this, means y is equal to complementary function plus particular integral. Okay, so now let's find the complementary function first. Okay, so to find the complementary function, we have to find the complementary function, we have to equate this f of d, it should be equal to 0. So this will be our auxiliary equation, f of d equal to 0. So you will get like d square plus d plus 1, it should be equal to 0. So from here you will get solution of d is like minus b means minus 1 plus minus root over b square means 1 minus 4ac, 4 into 1 into 1 divided by 2m, so 2 into 1. So you will get term like minus 1 by 2 plus minus root over minus root 3 divided by 2, or you can write minus 1 by 2 plus minus I into root 3 divided by 2. So here you can see you are getting the complex root here, you are getting the complex conjugate root here. Okay, so when you will get complex roots and complex conjugate roots, then what will be our complementary equation? You can see from this slide. If you haven't remembered it, then don't need to worry. You can see it from this slide. When you are getting two pair of equal imaginary roots, okay, sorry, no, not this here is the condition. Oh, a pair of imaginary roots. Okay, we are getting a pair of imaginary roots. Okay, where alpha represents the real terms and beta represents the imaginary term. Okay, alpha plus I beta and alpha minus I beta. So you are getting like this: e to the power alpha x, c1 cos beta x plus c2 sin beta x. Okay, so here our alpha and beta are in this case our alpha is like 1, this is our alpha minus 1 by 2, and beta is your root 3 by 2. Okay, alpha is your 1 by 2 and beta is your root 3 by 2. So you can write complementary function is equal to e to the power alpha x. E to the power alpha means minus 1 by 2 into x. Then you have to write cos beta x. So here you can write c1 cos beta x, c1 cos root 3 by 2 into x plus c2 sin root 3 by 2 into x. Okay, so you now will be your complementary function. This will be your complementary function. Now let's find out particular integral. So particular integral you will get like this: 1 upon f of d and capital X. So here your function of d is your this is your function of d square plus d plus 1. So write it d square plus d plus 1, and capital X is your cos 2x. Okay, So if you will compare with this cos 2x with cos ax plus b, okay, so here you will get a is like 2 here, okay, a is 2. So we have to replace our d square term with minus a square. So we have to replace d square is equal to minus 4 in this equation. Okay. So now if you will replace d square equal to minus 4, then you will get 1 upon minus 4 plus d plus 1, d plus 1, and then cos 2x. So you will get 1 upon d minus 3 into cos 2x. Okay, so here now you can't solve it further because you are not seeing any d square term here. Okay, you can put d square equal to minus a square, but now from now onwards you are not seeing any d square term here. Okay, so to get the d square term, we will multiply this with d plus 3 in numerator and denominator. So you will get equation like this: d plus 3 divided by d plus 3. You are multiplying it in numerator and denominator. So you will get like this: d plus 3 in numerator and d plus 3 in denominator. Okay, so you are getting like this. So if you solve like this, then here a plus b and a minus b. So here formula is like a plus b and a minus b. So you will get term like a square minus b square. Okay, so here you will get now d square term. D square minus 3 square means d square minus 9 here in denominator. Okay, so you will get like this. Particular integral will be in numerator you will get like this d plus 3. In denominator you will get like this d square minus 9 into cos 2x. So now in denominator you are getting d square term. Okay, so as you know, you can replace d square with minus a square. Okay, what is a here? A is equal to 2. So let's replace d square equal to minus 4. A is equal to 2, so a square equal to minus 4, a equal to 4, and this is minus. So now you will get like this: d plus 3 and d square equal to minus 4 means minus 4 minus 9, and here you will getting like cos 2x. Okay, so you will get like minus 1 upon 13, and yeah. Now what is, now see this, what is this? D plus 3. Okay, d plus 3 and cos 2x. As we know, d represents the differentiation. Okay, differentiation means d by dx. What d is representing? D is representing d upon dx. Okay, so now let's multiply this d by d with cos 2x. Then you will get differentiation of cos 2x with respect to x. So you will get minus 1 by 13, and here you will get differentiation of cos 2x means minus sin 2x minus sin 2x, and multiply with 2. Then multiply this 3 with cos 2x means plus 3 cos 2x. So this what you got is your particular integral. Let's suppose plus 1 by 13. Let's multiply this minus inside, then 1 by 13, 2 sin 2x, 2 sin 2x plus 3 cos 2x. Okay, this is your particular integral. So now you got both particular integral and complementary function. So now you can write your final answer. Final answer means complete solution. Complete solution means y. Y is equal to complementary function plus particular integral. Complementary function plus particular integral. What is your complementary function? Let's see this. This is your complementary function. This is your complementary function. Write it. E to the power minus x by 2 c1 cos root 3 by 2x plus c2 sin root 3 by 2 x This is your complementary function completed plus particular integral. What is your particular integral? This 1 by 13, and this term is your particular integral. So write it, plus 1 by 13 2 sine 2x minus 3 cos x. Okay, so now you got both term. Now you got the final answer. This will be your final answer. Okay, now let's see our solution of challenge question that we have given in my previous lecture. Okay, so now let's see this question. If the given it is given that y double dash plus y2 y dash plus y is equal to 0 and y0 equal to 0, y1 is equal to 0, then what will be value of y 0.5? Here you have given equation like this. It means it is a equation like this: f of dy is equal to 0. Here capital X is your 0. So here you don't need to calculate the particular integral, only you need to calculate the complementary function. Okay, here what is asking? First let's see what is asking in this question. In this question, y 0.5 it is asked. Okay, so means what is the value of y when your x is equal to 0.5? So to know the value of y when x is equal to 0.5, we have to find the equation of y in terms of x. So then only you can know this. So finding y means finding the solution of this equation. Okay, so here y double dash is written means it is a d square y upon dx square. So we can write it like d square y. Okay, so now write this equation in like this, f dy. So you can write it like d square plus 2d plus 1 into y is equal to 0. Okay, where this represents the function of d. So now let's calculate the complementary function. For complementary function, we have to find the root of d square plus 2d plus 1 is equal to 0. You have to find the root of this. So this represents the d plus 1 whole square is equal to 0. So it's a square term. So you will get roots of this is like minus 1 and minus 1. You are getting two roots and they both are equal. Okay, so when we are getting equal two real and equal roots, then we will get solution like this: c1 plus c2x e to the power m1x. m1 is like here minus 1, so you can write like minus x, minus 1 into x, or you can write like minus x. Okay, so this is your complementary function, and this will be your final answer also. So you can write like this: y c1 plus c2x e to the power minus x. Okay, so this is your complete solution. Okay, now it's in question y 0.5 is asked. Okay, so you can put x equal to 0.5, but you don't know the value of c1 and c2 here. Okay, so you cannot calculate exactly. Okay, so to calculate the value of c1 and c2, we have to find it by these initial conditions given here: y0 is equal to 0 and y1 equal to 0. You have to find out with this initial condition. Okay, so let's find out this initial condition. First initial condition is y0 equal to 0. So y0 equal to 0 means y0 is equal to 0. It means your y is equal to 0 when x is equal to 0. So now put x equal to 0 and y equal to 0 in this equation. So you will get 0 equal to c1 plus c2 into 0 into e to the power minus 0. So you will get here c1 is equal to 0. Okay, so now you got the value of c1. To get the value of c2, let's apply a second condition. Second condition is your y1 equal to 0, means y1 is equal to 0. It means y is equal to 0 when x is equal to 1. So now put this in our this solution. So you will get 0 is equal to c1 plus c2 into 1 into e to the power minus 1. So here you will get c1 plus c2 is equal to 0, and as you already know c1 is equal to 0, so you can get it like c2 is also equal to 0. It means c1 and c2 both will be 0. So your final y will be y is equal to 0 plus 0 into x e to the power minus x, means your whole y is equal to 0, means your y is equal to 0 for any value of x, for any value of x, means y is not depending on the x, it will be always 0, y will always be the 0. Okay, so for y 0.5 or for any value of x, your y will be 0. Now let's see the options. So here in option A you are getting a is equal to 0, but uh, hey guys, if you have seen my get tips related lecture, then there I have said this earlier. When you are getting any unusual option in answer, then definitely their probabilities increases. Like in this question you can see a option is unusual, means here it is 0, rest all of the option is like numerical values 0.37, 0.62, 1.13. So it is like some numerical value and it is different. Okay, so when you are getting like some different options, so their probability increases. Okay, to get succeed, it is my general observation, it's my experience. Okay, so in this question also, as you can see, you are getting some unusual option like a here 0, and its answer is a. If you haven't seen my that get tips lecture, I will recommend you to watch that lecture. That is really important lecture. Okay, that lecture you can find in my comment in my description box. Okay, watch that lecture. Thank you, and thank you for watching this lecture, and like us and subscribe my channel, and you can ask me any question in my website lecturesforfree.com. You can also download my handwritten notes. There you can find more examples related to this topic. Okay, thank you so much.